All right, we still have part B to figure out for the applicability of the Rolle's theorem. This time our function is sine 3x, the interval is pi over 2 and 7 pi over 6. Well, the good news is that we know from the chapter, from the earlier chapter, that we have a trig function that is continuous all the way and as well differentiable. In other words, this function is continuous and differentiable on the whole real axis, and obviously it's going to be continuous and differentiable on a smaller interval, pi over 2 and 7 pi over 6. So for this problem, for this case, we're going to only check if the function values are the same at the endpoints of this interval. Right, we're going to check f at pi over 2 and f at 7 pi over 6, and then punch in sine 3 times pi over 2 in your calculator, as well as sine 3 times 7 pi over 6. But don't forget to set your calculator to the radian mode because these inputs are in radians. And in one case, you're going to get sine 3 pi over 2, which is 0. In the other case, you're going to get sine 7 pi over 2, that is also 0. So the good news is that the function values are exactly the same at the endpoints. So the secant line connecting these 2 points is horizontal, so that comes with slope 0. So then all 3 conditions of this fact are satisfied, so we are guaranteed at least one number c in the interval pi over 2 and 7 pi over 6, for which f prime is exactly equal to 0. In other words, we have a horizontal tangent line at that point, or points. All right, the Rolle's theorem doesn't tell us exactly what those points are, so we have to find them. And how do we find them? Well, we're going to find f prime and set it to 0 and solve that equation, and those solutions hopefully are going to tell us what those points could be for the interval pi over 2 and 7 pi over 6. Right. So f prime of x for this problem is the derivative of sine 3x. So why don't we use the chain rule to take the derivative here? So the outer function is sine, inner function is 3x. So the derivative would be cosine 3x, which is the derivative of the outer function, times the derivative of 3x, the inner function, that is just 3. All right, now what we're going to do is to set this to 0 and solve for x. Well, first thing is to get rid of this 3 here, so why don't we divide both sides by 3? So essentially we get cosine 3x equals 0. At this moment you step back and recall certain properties from trigonometry, which we went through in pre-calculus. So just ask yourself, like, whose cosine is 0 in the interval 0 and 2 pi, for example. And then you can go back to the unit circle and you can check the points whose x entry to be 0. And you can find out that those points are pi over 2 and 3 pi over 2. So this is how you use the unit circle for this purpose, but also you can use your calculator to come up with x. In fact, 3x here is going to be cosine inverse of 0. Okay? And if you punch in cosine inverse of 0 to your TI-84, there's going to be only one value popping up, which is pi over 2. But we have a lot of other points for which cosine of that 3x equals 0. In fact, you can find those by adding integer multiples of pi. So those integers could be also negative as well. So for example, pi over 2 for n equals 0, 3 pi over 2 for n equals 1, 5 pi over 2 for n equals negative when n equals 2, and on and on and on. And you can use the negative versions of those. But these are all 3x, right? So we should probably divide these by 3 so that you have pi over 6 plus n pi over 3. Okay? So the x's that we're after would be pi over 6 plus the integer multiples of pi over 3. Right? And remember that the interval is pi over 2 and 7 pi over 6. we can go ahead and check what's going on with n equals 0. So for n equals 0, it's pi over 6, which is not in that interval. And for n equals 1, this is pi over 3 plus pi over 6, but that's pi over 2. And that is the left end of our interval, and c cannot be an endpoint. So in this case, pi over 2 is not even a solution for us. So we're going to try n equals 2. So that's pi over 6 plus 2 pi over 3. All right, here is the graphical outlook of sine 3x on the interval pi over 2 and 7 pi over 6. And we found only one critical point, that was 5 pi over 6. If you look at the secant line connecting the endpoints, as you see, we have exactly the same function value at these 2 points. Well, it is a horizontal secant line, as you see, once you connect those points. Our analysis provides us, as the conclusion of the Rolle's theorem, we have a point 5 pi over 6 where we have a horizontal tangent line, and here we go, and that's the only horizontal tangent line happening in between pi over 2 and 7 pi over 6 for the function sine 3x. And this verifies our analysis, and also this ends the video. Thanks for watching. I'll see you in another video. Bye.